Welcome to the WinRiverII Introductory Training Course. My name is Dan Murphy and I work in the Field Service Department at Teledyne RDI Instruments, where I respond to customer emails and phone calls regarding Teledyne RDI Instruments products. I have been with the company for 10 years.
You can see the ASCII output is included in the big picture on the right hand side. Just above it is the hydromal file that can be output by clicking File, Export as Hydromal. The navigation, depth sounder and external heading files are created automatically by WinRiverII when the data is being collected, assuming these inputs are present. The classic ASCII output is the same as WinRiverI's ASCII output. This is a fixed format output. The focus of this class is the generic ASCII output. With the generic output, you can select any and all of about 400 different items, such as water velocity, water direction, water depth, etc. Click Configure, ASCII Output, Generic ASCII Output. If this is the first time you're opening the wizard for this particular measurement, then select Create New ASCII Output Template. If it is not the first time, then you can load or manage an existing template. The template is simply a list of what values you want outputted and in what format. It is not the output itself. We will see the actual file output later on. On the left panel is displayed the beginning of the list of all the items you can select from and output. The WinRiverII User Guide Table 5 contains a list of all of these items. They can be bin or ensemble or transect based. They can be discrete, incremental or cumulative. Finally, there are brief comments on the meaning of the outputted values. In this example, we will start off with the ensemble number and the GGA latitude and GGA longitude. It is useful, though not necessary, to include the ensemble number. If you're not experienced, it is also advisable to start off with a small number of values and build up slowly and check against the appropriate tabular. Otherwise, the output file can become a bit overwhelming due to all the values being outputted on a single line for each ensemble. In particular, we output all the bins regardless if they are good or bad. Select a parameter delimiter, comma, space or custom that will be suitable for your processing application such as Excel. Select the message delimiter. Card return line feet is the default. The ASCII output can be sent to a serial port, but more commonly to a file. If a serial port is selected, the data will be outputted in real time during data collection, that is, during the transect. Click to File to save the template file. The file is a .ttf and should not be edited using an editor. After proceeding to the end of the wizard, you will now see the ASCII output name in the measurement panel under each of the transect file names. Here it is highlighted in red. At this point in time, the file will be empty. It is necessary to reprocess the data for the file to have its contents. Once you reprocess the transect, depending on the transect size, it may take several seconds or longer. Wait until the progress bar is complete and the intensity profile and the velocity contour have data displayed in them. Next, double-click on the ASCII file. Use the slider to select an ensemble number, for instance, in this case, 1000. Find the ensemble number in the file. Compare the ASCII results against the tabular. They will be the same unless you selected the wrong values in the template earlier. Note that the ASCII GPS values are in decimal degrees and the tabular numbers are in decimal minutes. That is why they look a little different. Next, we will output velocities and directions. Reference the bottom track. In the case of bin data, the output will contain results for all the bins, whether they're good or bad. Bad is represented by the number minus 32,768. I put the ensemble number between the magnitudes and directions so that you can easily see the end of the magnitudes and the beginning of the directions. This is not necessary, but I found it is useful when using Notepad to look at the data. Note the existing template and the new highlighted one. We could have added to the existing one. Both ASCII files are now visible. Only one has data until we reprocess the transect. The magnitude values in the ASCII file can be seen to correspond with the values in the earth velocity tabular. Check the yellow for yellow, red for red, blue for blue, and so on. This serves to show that you have the correct and expected values in your ASCII file. The directions match. Note that we are now in the middle of the ASCII file, as you can see from the yellow highlighted mark on the bottom of the ASCII file. The magnitudes are at the start of the row and the directions are at the end of the row. Again, you'll notice that the directions highlighted in yellow, red, and blue are all correct. Notice the bad magnitude bins, minus 32,768, before the directions begin and ensemble number 1000. This is because all the bins are outputted. If you decide to make any changes to an existing template or create a new one, it is necessary to reprocess the data. Otherwise, the data in the file is stale or the file is empty. This is a list of our existing courses, and you can go on the web and look at any of those existing courses. This course is the ASCII Output, and the next course we will present will be the WinRiverII compass calibration. Also, we will have a course on running WinRiverII on your tablet. Thank you.